Hello, good morning. So it's data science and coffee. We're still working on that autism spectrum disorder. So today, this is an extension of the data science and beer last night, and then that from the data science and coffee that morning, and then the data science and beer before that. So, yeah, we already found our top gene bank accession IDs, but we don't have genes to them because of the way this data is put together. But we did get about 47 gene bank accession IDs. We're going to now manually go into the NCBI site and we are going to add those gene bank accession IDs individually, one by one, get the FASTA sequence, copy and paste it into the BLAST website, the basic local alignment sequencing tool, search tool. And then we're going to click the genomic and transcript selection, open in a new window, and then we're going to go on to the graphics and we're going to pick the top actual genomic link that it has to it, not the predicted ones. And then we're going to go into the graphics. And then we're going to look at the chromosome and we're going to zoom in and out. And we're just going to look at where our query is and what genes are in that location of the chromosome, locus, loci. And then we're just going to add it to our data so that we'll get top genes. Okay. Sounds fun, huh? All right, let's share our screen, my screen. Window, entire screen. Okay. So also share system audio. I don't think we'll be needing that. I didn't even check, but my microphone's on, so it should work. Okay, so we're gonna do that. Let's get started. You can go to the RPubs website to get the last document and download it, and then open it up in your RStudio. So it's rpubs.com Janice Corona, and it's this one. And then you would just share it. I'll just copy it and I'll put it in the chat. And then you can. I don't need that window open actually. Let's see. We'll put it here. And then I'll also put it on the details of this, but afterwards. Okay, and then that's where we are up to right now. We're going to just run everything. So hopefully you have a fast enough computer and you're not just using a cloud computer that you can, unless you have storage on the cloud and you can access it. I haven't tried those new PCs, but they don't come with a keyboard or a monitor anymore. You just buy a box and it's a computer for like, you save like a couple $100 off of something like this. All right, so we're going to the autism folder, and we've only had this one. It's part one, but it's actually all of the parts that we've been doing to it. We have done a lot of work on it. Here we go. So we're just gonna run all of it. Let's just start in RStudio. Just make sure that we're in the right directory. Set as working directory. You'll see it right there. I'm gonna move this out of the way too, because you guys get to see that. It's the stop sharing screen. All right, so we're just gonna run all the chunks. I got food going, so I'm gonna make sure it doesn't burn or make a mess. It's just stewing some chicken thighs and ginger, peppers, bell peppers, jalapeno peppers, soy sauce, minced onion. I didn't add garlic this time. My hands are full. And olive oil. And I took the chicken fats off and I put some seasoning on it, steak seasoning. I'm gonna put it in the toaster and it's on right now too. That's what you hear with the timing. And that I'm gonna feed to my dogs. So hopefully that turns out crispy and nice for them. I won't feed it to them hot either. All right, let's just run all this code. And while it's running, we can just look. These are all the individual files. We can just look at this one. This is what we wrote out. We saved this database. So we're actually just going to use this top GBIDs. That's the one we're going to be using. Top GBIDs in here. We could also just manually do it in Excel. That would probably be easier. But yeah, we don't really need to do that because then we have to like go back and forth. So top GB. What was it? IDs. Top GB ID. Gene bank ID. Okay. So let's just. This is a useful way if you really want to help out someone who's suffering to just give your time and your work to finding these genes and understanding their condition. If you have the time, that's better than money. Also, you can just give all your money to that. Wonderful as well, I'm sure. Keeping enough for yourself to survive, of course. You could totally get lost. You could do anything with us. You make those genes public, you publish it, other researchers and students and such are looking at that stuff and they're like, is there a connection? What's her? Oh, and then chemists are like, oh, we're gonna do some kind of project final. Let's go into this area. It's really big. So yeah, the more you put out there, someone will be looking and probably connect with it and use it and then get what you want and then things will happen faster. Okay, so the data set we are using is, and we are going to basically do what I just said. I'm just going to type it basically. Look up each of the 47 gene bank accession IDs and get the FASTA sequence of nucleotides and copy and paste that into the BLAST site and select the genomic plus transcript. I think it's just something like that, similar transcripts. Because it's genomic, we know this because it's complementary DNA. There's a T in the nucleotide sequence. If there was U, it would be RNA, messenger RNA. But you can also put that in genomic and transcripts. It understands it, I believe. So I haven't used it in a while, but for that reason, for that stuff. But it was within months, so that's what I remember. Similar name. And then open in a new window. It looks like it ran everything to get the, I'm just writing this out. Some people learn better. I learn better when I can read it because sometimes things just happen too fast when you hear it and you're just like, you're probably distracted by how I look instead of like listening to what I'm saying. So if you like look at the words, you're like, oh, that's what's going on. Okay. The top. The top genome selected by BLAST is the basic local alignment search tool. The basic local alignment search tool. And then click that top ranked gene location. So locus, Loki, and then go to the graphics link and select it. Then search for the query and the neighboring genes near it. Okay, we're gonna do that. So let's go ahead and page table top GB IDs. We've already attached all the samples to it. And so we have 116 samples, but it's to see which, because not all of these genes are top gene locations for every sample, because some of these, we took them from the bold changes of 3 types of autism spectrum disorder compared to the healthy samples in the set. There is a fairly even balance of samples for one. So there's the language type, the mild type, and the savant type. So we got the savant at the end, mild in the middle, language in the front. We have 47 rows. Those are observations. So those are the genes, gene bank accession, but they're not really the genes because that's actually just the chromosome location that some other, if it has an ID, that means it has been found. But there was no other way really to get that name because we had to get rid of some blank ones also that weren't even in the platform they used. So whatever those ones were, they could have been holding some information. But since they weren't identified, or maybe they were just errors in the processing, gaining of that gene expression data, we don't know what they were, so we dropped them. There would have been 60, but no, there were too many blanks. So there was 13 blanks. We got 47 genes. So we're just going to manually go to each one. So we got let's just do by the gene bank accession. We'll find out what they are first because we can later merge this. Top GB IDs. Oh, look at Miss Zena. She's so hungry. I give her snacks all the time, and she always eats. She just loves me. She's so sweet. Oh, we're just gonna go by that feature, and we'll see all the gene bank accession IDs. That's what we're working with. So what we're gonna do is just look up each one, and then we'll just put it in there. So we got our list. Let's just copy it. And we'll put it in here. And then we will just make, these are the GB ACC IDs we will find. And then we're just gonna make a list within our markdown. You have to make sure there's 2 lines between the last line, put the hyphen, and then 2 spaces between each one. And then after this, and I believe you have to do a line between each one. Or, yeah. So we'll just do that. Let's just get them on its own little row first. And we will just find these genes and just add it manually. We'll go ahead and delete that one. That's what data science is mostly, just putting all this information together. Sometimes you have to go find stuff and it can take a while. After this, we'll get rid of the quotation marks using the search tool. We'll substitute the quotations for nothing. So we're just still making that list, just, there's 47 of them, so we have to make sure we don't cut off any of the ID portion of these gene bank accession IDs, because we are manually needing to search each one and then get the genes located near it. And we can just copy it, and let's just go ahead and, we'll, okay, so right here, and we'll just copy this. Control C, Control V, enter, 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 Control V. And you get it. We're just gonna keep doing this down the row, the line, the row, the column, down the column. Right. Yep, still doing it. Got a few more to go. Then we'll use our search tool. To find and replace the selected text of the quotation marks for nothing. All right, so we're done with the 47 make one list. Now we're just going to select all of this. Okay. Make sure it stays selected. You have to make sure this checkbox is selected too. We're going to replace all quotation marks with nothing. Okay. And it says 94 occurrences replaced. We'll just go down the line and look down each row of this. Okay, list. All right, so we have everything. Let's save it. I'm starting to smell my chicken cook. I gotta go stir it. Multitasking. All right, let's see. So going over here. Cooking up pretty nicely. Some chicken thighs. Everybody in this house likes the dark meat. We like the chicken, the white meat with salads and fettuccine. But when it comes to just eating by itself or vegetables, it seems to have more flavor with the dark meat. I have to be careful I don't leave this on the counter too long because my dogs get up here and destroy it. I already replaced the whole set. And then they got into more utensils that I left in the dish drain. All right, so now that you guys are ready, let's go ahead and go to that website. We got to look up each one in the NCBI, National Center for Bioinformatics Information. Gene expression. Data. I already have it up here, NCBI gene study. You just search for it. Let's just go ahead and get the first one. We can work from the bottom up, we can work from the top down, in the middle, whatever, but just make sure you got the right information. So this is our first one. We're gonna go ahead and Control C, copy that on a PC, and Control V, paste, search, just copy and paste it. Here we have a FASTA. This is what we want. You don't have to click on the actual number, just click on this. Oh, actually, there's a BLAST link too right there. I haven't tried that one. We could have just done that too, maybe. Let's see. Let's just go to BLAST. Okay, BLAST. Oh, we can look by accession number. We could just go right to BLAST. Look at that. Sometimes we do things, we don't even see things. Told you guys I wasn't good with puzzles. So, and I get bored doing the same thing over and over again. So I have to always change it up a little bit. All right, show it in a new window. Make sure you check this genomic and transcript databases. Human, too, because they do have moose, musculinus, and other types of mammals. It's searching. This is a query search. Okay. And then we're going not to the transcripts, but because those are like the predicted ones. I just chose that. I mean, if you want to, fine, but I don't know if you'll see the chromosome. We'll go to the genomic sequences. Top ranked one, you can see if there was more, the score right there, it's the highest one. That's per percent identity of that sequence. So we're going to just click on this first genomic sequence. And you see, it'll have all these queries and stuff. We're going to pick the graphics, okay? Now, when we go to the graphics, there's a chromosome. Here's our viewing window. This is where we are living at. This is what we're looking at. These little green splatters are the genes near it on that chromosome. We're on chromosome 6. Okay. Damn it. My mouse pad. Okay. So right now our query is this. That's our gene bank accession number. And it's been already identified in fetal liver spleen disorder, which is a baby's liver and spleen. Okay, so that's where we are. This right here, this block, this gray block, see it? We're gonna zoom out. You'll see the block shrink. Now notice there's arrows on this one. That means it's going on the reverse strand. Sometimes it'll say the reverse strand or the forward strand, but if it's going to the right, that means it's the reverse strand. If it's going to the left, the arrows go that way, it's the forward strand. And it's complementary DNA. Usually the reverse strand is the complementary DNA. I don't think it's really relevant, to be honest, because it's the gene, but I guess if you're a chemist, it makes sense to you to do that. And then this bar right here is just, I believe it's just the chromosome. So we are on P, on a chromosome, there's different chromosomes, and there's a centromere at the center. And then above it, I believe, is the P arm. Below it is the Q arm, because it was two sister chromatids that got together in mitosis, and then they're in the nucleus of a cell that's very tiny small cell, even tinier nucleus surrounded by organelles inherited from your mom. So we could see right here, there are some other genes nearby. So let's just keep zooming out and then see if we see any more genes. Now see how small our sequence is on this chromosome right here. It's within whatever this number is, probably like 70 something million to like 90 million. It'll actually tell you when you link on it. It'll tell you where it's at or hover on it. So this is at position 54,210,247. So it's identified in 97% of our search. So What is this gene? Let's just look. This gene, it's not saying it's anything. Oh, it's MLIP. So you know what? There you go. We got a gene. It's MLIP, muscular LMNA interacting protein. That's the closest gene. There's nothing else there really, unless you go further out. So we're just going to keep that gene, but I want to close that. What is this? Somehow it opened up. Okay. Just hover over it and you'll see it. And there's a locus right here. Something in a research showed this. That's near it. But really what we're getting at is this MLIP. So there you go. We got our first gene from this gene bank accession. Oh, darn it. That sucks. Okay, let me see. Well, I mean, it's up here, so it doesn't really matter. Come on. Sometimes that happens if I accidentally press the space bar. We'll just copy and paste it right there. Okay, so for this one, we're going to just put, yeah, so it's just our manual list, so we'll have to, again, go ahead and put this in that one. We can also just make a vector up here, and we're just going to call it genes to GBACC. Okay, and you sign it. We're calling it first. And the first one, this is a character string, is, let's just make sure we spell it right, MLIP. Okay. MLIP. That's our first one. Now we could just do that. Let's control S it because it's not going to get saved in your history, this one, because we never ran it. So we'll go back to our environment. And our next one, we'll just, whenever this happens, we'll go ahead and we'll just note that we did that. We'll just put a comment in LIP that we went through it already. Because this is not code, so we're fine. Next one is T86983. We'll just copy that. And then we're going to go back to our window. We can close these windows out. And our next accession number is this one. Now we got our genome and transcript databases selected, search in a new window open, and we're just going to press that button. And then it has a genomic sequence, 97.07%, and only has one. So it's chromosome 17 right here. Gosh, dang it. My mouse pad is so sensitive. Here. We selected the graphics. Now we're just going to look for these genes. There's our gene bank accession number. You can see it's pretty large gene. And we're hovering over it. It's telling us that. What's this one that's overlapping it? There's only one overlapping it. So let's just speed things up. It's R, pain, just like the word pain, but it starts with an R. Oh, got to put it in quotation marks. And let's make sure that okay, now we go to the next one. Let's control S, save it, because don't want this work later on to get destroyed. And we're going to go ahead and search for our next gene bank accession number. So for that one, we'll just close this window, close this window. We'll go back to the original window, Control V for our new third gene bank accession ID. This is selected genomic and transcript databases. Highly similar, shown in a new window, blast. We're just waiting for it to query this gene. And we're going to the genomic sequence. We have a few of them. Sometimes there's like a whole list. A lot of the times there are 100%. So different chromosomes. We're going to just go to this first one. We're going to go to the graphics. And it looks like there might be 2 genes here. There's one on the forward strand. Okay, so here's our query. R93875. Wait, no, it's not that one. It is R93875. And let's just zoom out. It's this bottom one right here, and there is one gene for sure overlapping it. It's on the forward strand, and it's NAP1L1. 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 Okay, now we're on to our 4th gene bank accession ID. Let's go ahead and make sure we did this right as well. NAP1L1. Okay, great. So we'll go ahead and close these 2 windows out. We're going to go ahead and get our 4th gene bank accession ID. And then we're going to paste it in our new query box on BLAST. And we will go look for it. As it searches. We're going to go to the genomic sequences. There's 2 listed. They're both about the same score, and they're both on the chromosome X. So we'll just go to the first one. We'll go to the graphics. We'll look at the chromosome. Here's our query. This long gray box when we hover over it, that's what we just searched for. Now we see 1 gene. There's only 1 gene in our window viewer. It's a long gene. It's this gene, forward strand. It's septin6. Septin6. Okie doke. Let's go ahead and write that down. And then we'll go for our next one. Let's Control S, save that. We've done 4 genes now. So we have 43 more to go. You're doing great. So we'll go Control C on that one. And let's close these windows out. We're going to put this in our query box. We just entered the correct gene bank accession. Make sure these are all selected. They should be because it's the same window, but you never know. If not, you'll know because it won't show up what you want, and you'll have to go back. And we have 1 genomic sequence. We'll go ahead and select that with 96.77%. Identification, graphics, going into the chromosome. And here we have our query, this long box. That's great. And we see 1 gene above it. And in our search window, that's pretty accurate. It's on the reverse strand. And it's CFAP144. So C, FAP 144. Let's make sure I set that right. CFAP 144. CFAP 144. That fly distracted me. So you always got to double check too, because CFAP 144, CFAP 144. Okay, great. Now 42 more to go. We'll copy the next one. The next one is R38 172. We'll go ahead and go there. R38 172. All of the selections are selected. Go ahead and search for it. And there's a lot of persistent ones. Only one genomic sequence, 94.89% identity. Okay. Going to that chromosome 2 on this one. Going into the graphics for it. Searching for the genes next to it. Or gene. So far, it's only been one gene. Okay. All right, there we are. That's what we're looking for. And there's one gene on the reverse strand. It is RIF1. RIF1. We'll go into that and keep it RIF1. Give all the RIS to somebody else. All right. All right, and so now we're going to go into the next one. In 62522. Actually, okay. We're going to get rid of the RF1. We're going to close out these windows and go search for the next one. In 62522 is our gene bank accession ID. Everything's checked. Go ahead and blast. Yep, we're just searching for this. Still searching. I'm going to close out some of these windows that I'm not using. All right. And then here we go. This is our search menu. Genomic sequences, 1, chromosome 1. Select that. Going into the graphics for this gene bank accession ID on chromosome 1. We see there's 2 genes now. So this is our search 62522, and then we have 2 genes. We have this one on the reverse strand. It's SLAM F8. Then we have one on the forward strand, SNHG28. Let's just zoom out and see. So the SNHG28 seems like it's probably a larger gene, but this other one goes back pretty far too. So let's just see where it's at in location. Here we are with our search. And now these are the 2 genes that overlap it. So we have SLAM F8. We'll put that one. This one has 2 of them. And then also the other one is You'll see this many times, actually. There's quite a bit that have overlap with other genes. SNHG28. SNHG28, the other one's SLAM F8. SNHG28. SNHG28. Okay. So for this one, since we have two, we'll just note it, but when we merge it, we got to select one or do multiple. Okay. Yeah. So, wow. All right. I'll just, I'm going to just have to put and. SNHG28. We'll just have to manually go in there and select one or separate it into a separate column and just run different sets with it. All right, now Control S save. Let's go on to the next one. 1, 2, 3, 4, 5, 6, 7. Only 40 more to go. And we've spent about 38 minutes on it. Let's see. How long did we spend? Let's see. I tell you guys are having so much fun. 40 minutes doing that, and we only got through a few, but it's important though that you get the right gene in there. So we'll go ahead and get rid of these extra windows, and we'll just manually track our time while we do this. I told you could get lost in something like this. But it's okay because we're gonna find out more information as we go. We were gonna do a 4-class model, but right now we need to get this done. So we don't actually need to do it. It's just we already entered this game, so we have to finish it. Okie doke. N51 529. Okie doke, that's the right one. Let's go ahead and make sure everything's selected. Genomic and transcript databases. Highly similar. Open a new window. Blast. Basic local alignment search tool. Let's blast this. Recorder. She's talking about bombs. No, I'm not. That's what it is. It's right there. It says blast. I don't even know how to do this. I didn't want to. Okay. And here we are. Chromosome 2-1, selected 95.99%. We're going into the graphics. And here we are in 51529. It's a long gray box when you hover over it. And we have one gene there. This one gene. TET3, TET3. So there we go. We're just going to put TET3. Okay. We'll go on to the next one. All right, let's Control S save. I have to get ready for work soon. We'll finish this at Data Science and Beer later because I don't have to go to work tomorrow. And I can't fix my truck tomorrow either because I won't have access to the driveway tomorrow. So, yeah. I can't do it Monday either because I'm getting my teeth cleaned. And then I might not have a vehicle to get there in time if I decide to work on it and then I get stuck. I know right now, though, I have to remove some of those heavy bars, and that might be a pain trying to get it up. So I'm going to have some tools nearby to do that. All right. So let's go ahead and paste whatever it is we have. Okay, age 63, 994. Let's check. Age 63, 944. Good. Now let's go ahead and search for this. It's selected, everything's selected, or that needs to be selected. Not everything, just what we need, the genomic and transcript databases. Okay, so that's the hour that went by for the chicken fat I was cooking for my pups. Looks kind of tasty. I think they'll enjoy that. We'll just let it cool off in there. As you can see, I took the chicken fat off. And there we go. Chicken thigh fats. See that? Put some steak seasoning on it with olive oil. And then when it cools off, I'll give it to my pups as a treat. It's the first time I've ever done that. Okay. Where are we in this one? Let's find out. Someone was talking. Stop talking, dude. All right, let's see. Chromosome 2. And it is what we were looking for. Age 63, 994. We're going on the 4th strand. There's only one. It's FT-CDNL1. So FT-CDL. And is it N1? Let's see. FT-CDNL1. Make sure there's not a period there. Okay. L1. FT-CDL. Wait, is it CDT-L1? Oh. FT-CDT-L1. Okay. Let's just zoom out and just look at it, because hovering just takes a little time. Let's see if it says it. What is it? FT-CDN-L1. 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 Okay. Let's go ahead and go up here. FT-CDN-L1. Okay. Now FT-CDN-L1. Here, Control S, save. So we're getting closer to this list. Right now, what we're going to do is move this down, because I'm gonna have to get ready for work soon, and that chicken is almost done. Thanks for joining. I'm going to go ahead and wait, hold on. Okay, actually, let me just manually with the mouse cut, and then we're gonna paste it right here. That's what we got so far. So we did 1, 2, 3, 4, 5, 6, 7, 8, 9 gene bank accession IDs. We have 38 more to go, and we're just gonna add it here. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. Remember, that was 2. That was 1 gene bank accession that had 2 overlapping genes. And we'll continue with this later. Yeah, see, you see? All right. I'll be picking this up later tonight with data science and beer. So I'll go ahead and stop sharing. I'm not sure what time, because I have to do chores after my dog. So we'll just rerun everything when we get back. Dang it. Okay, we'll close out of this. All right, so thanks for joining. See you later.